So this is the supplement for Module 1 vectors. Module 1 vectors, the supplementary lecture. In this lecture, I try to cover a few examples and talk about some of the notions that may not have been covered during the vectors, video lecture 1 to video lecture 5. So let's start with the graphical representation of vectors. So in the two-dimensional space, let me define vector A to be 2 and 4. So if I want to represent this vector, let's call the first element x sub 1 and the second element x sub 2. I'm going to have this axis. This is x sub 1, x sub 2. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 3, 4, 5, 6, 7. So if I want to represent this vector, I start from the origin and go to x1, 2, x2 equal to 4. So this is my vector A. Let's define another vector. We call it vector B. Vector B is 3 and minus 4. All right. So what we are going to have, 3, 1, 2, 3, and minus 4, 1, 2, 3, 4. So this is a representation of vector B. So the question is, how about in the three-dimensional space? So in three-dimensional space, we are going to have a vector, let's say vector A, with 3 elements. So I define my vector as 0, 2, minus 1. And then I call the first element x sub 1, second x sub 2, third x sub 3. So just to show it in the two-dimensional, in the whiteboard that we have, what I'm going to do, I'm going to call this x2, x1, and x3. All right. In this case, x3 is minus 1, x1 is 0, and x2 is 2. So this is going to be our vector. Another scenario could be where x3 is 0, and we only have x1 and x2. So let's define vector B. So we said x3 is 0, x1, 1, x2 is equal to 2. So we have 1 here, x2, 2, and this is our vector. So this is vector B that doesn't have any dimension on x3. So we could have vectors that all of these elements are non-zero, so they are going to be in the three-dimensional space. So they cannot be represented here. All right, the next concept that I want to review here is the direction and magnitude of a vector in the two-dimensional space. So direction of a vector in two-dimensional space. So let's define our vector x to be x1 and x sub 2. We also can show it with this notation. All right. The direction of this vector in R2 is going to be the angle that this vector creates with the x1 axis. All right. So if I want to show it geometrically, it is x1, x sub 2. This is our vector. So we basically want to measure this angle. Let's call this angle alpha. So how do we measure alpha? We say alpha is tangent inverse of x2 divided by x1. So this gives us the direction of our vector. How about the magnitude of this vector? The magnitude is similar to the Euclidean norm. So magnitude of the vector. So for the magnitude, we have norm of vector x, which is equal to square root of x sub 1 square plus x2 square. So now let's see an example. Let's define example of direction and magnitude of a two-dimensional vector. All right. In this example, I define my vector x to be equal to -1 and 1. So let's first represent vector x. So it's -1 and 1. So the angle alpha is going to be tangent inverse of -1, and the magnitude of the vector is going to be norm of x, which is equal to -1 square plus 1 square, which is square root of 2. Another concept that I want to overview in the supplementary lecture here is scaling vectors in the two-dimensional space. Let's say you have the representation of vector x, and then we ask you to represent vector 3 multiplied by x. So that's going to be the same direction as x, but 3 times length of x. So the length is 3x, but in the same direction. However, if it's multiplied by a negative number, let's say -2x, it's going to be the opposite direction, but the length is going to be twice. So the length is twice, but in the opposite direction. Another example could be 1 divided by 2 multiplied by x. So this is going to be half of the length of vector x in the same direction. And one thing is zero vector. So if you multiply vector x by a scalar 0, then it's going to be the 0 vector. Let's see some numerical examples as well. Vector x is equal to 6, 12, 3. So vector 2x is going to be 12, 24, 6. Vector minus x is going to be -6, 12, -3. Vector 1 divided by 3x is going to be 2, 4, and 1. And finally, 0 multiplied by x is going to be 0, 0, 0. So these are different variations of scalar multiplication in vectors. So there is this notation for representing vectors in 2- and 3-dimensional spaces. So any vector in 2-dimensional space can be represented as sum of unit vectors I and j. So what are I and j? If you remember, we said we can represent vectors as x sub 1 and x sub 2 in the two-dimensional space. So we call this one I with length of 1, and we call this one j, again with the length of 1. For example, vector x is equal to 2 and minus 5. We can represent this as 2 multiplied by I minus 5 multiplied by j. And I and j are vectors themselves. They have directions. This is holding actually for the three-dimensional vector as well. So any vector in three-dimensional space can be represented as sum of unit vectors I, j, and k. So what are I, j, and k? So we have this three-dimensional space. x1, x2, and x3. So we call this I, call this j, and we call this k. So for example, if I have vector y equal to 2 minus 1, 3, then we can represent it as 2 multiplied by I. You can use this notation, this symbol for vector. You can also dismiss it. It's not necessary in our course. So minus j plus 3k. Or alternatively, as I said, you can say 2i minus j plus 3k. So this is the same representation as showing it as this vector. So now let's see a few examples about adding or subtracting vectors. Let me define vector x to be minus 1 and 5, vector y to be 0, minus 3, vector z to be 2 and 2. All right. So the first question, what is x plus y minus z? All right, x is minus 1 and 5, plus y, 0 and minus 3, minus z. Instead of minus z, we can say plus, and then multiply minus 1 by z. So this is minus z. So now we are going to add the first elements together. Minus 1, 0, minus 2, minus 3. And the second elements together, 5, minus 3, minus 2, 0. So the answer here is minus 3, 0. The second question, 2x minus y, what's the solution to this? So 2x is 2 multiplied by minus 1 and 5, minus y. Y is 0 and minus 3. So it's going to be minus 2 and 10 minus 0 and minus 3, which is going to be minus 2, minus 0, minus 2, 10 minus minus 3, which is 10 plus 3 or 13. This is going to be minus 2 and 13. So these were a few examples that I wanted to cover for vectors. With this, we conclude vectors with 5 parts of main lectures and 1 supplementary vector.